this always annually? It's never.
I think this problem is always
Monthly
annually. There's
or
another problem, which which we're not on yet, that has some different words in it. So, and it varies by person. So let me give you all the words. Semi-annual compounding.
So that's 2 times a year.
That's 2 times a year.
Okay. I think we're used to annual, bi-monthly, and monthly.
Yes. Also quarterly.
Oh yeah.
Quarterly is 4 times a year, every 3 months. Bi-monthly is 6 times a year, every other month. And then monthly would be every month, so 12 times a year. And when I say times a year, that means how many times a year are you being paid interest? So how many times are they doing calculations? Now, there's another way that they can do the calculation that they do sometimes just to make their lives easier. And that is called continuous compounding. Now, how many times a year do they compound it with continuous compounding?
60?
That would be daily. Continuous is infinite compounding. They compound all the time. It's continuous. Now, does that equal infinite money? Unfortunately, it does not.
Would that be every day?
It's just all the time.
But that sounds great. Who wouldn't want to do that?
No, it doesn't work like that, unfortunately. It's not a, for continuous compounding, they use the formula S equals PE to the RT power. It's called the PERT formula. The PERT shampoo, if anybody's old enough to remember that.
Yeah.
Yeah, why is there a formula for something that never happened?
No, it does happen. It does happen. They do use that.
For what purpose?
It's easier to calculate. It doesn't actually give you that much more money. It's not like continuous compounding. It's not like you're continuously getting money.
So P is your principal.
Okay, P is your principal, R is your rate, T is your number of years.
Oh, let's see. They have the E in there.
E is the number.
Is the number?
E is the actual E on the calculator.
Okay, E on your
That's what
I was meaning.
Yeah, not a variable.
That is easier.
Now you would think like continuous compounding would give you so much more money. It really does not. Compared to like daily compounding, it's really not that much more money.
We can put it inside a graphing calculator. We can put it inside a graphing calculator and compare it.
You can compare it, yep. Let's do this problem though. Let me find the continuous compounding problem.
Can you graph the regular compounding?
Okay, graph a function gives you future value of 40,000, invested at 5%, compounded annually for 12 years. So if my future value, the future value of 40,000 just means I'm investing 40,000. So 40,000 would be my principal. 5% would mean my R is 0.05.
Can you not graph this?
No, you can graph it. Hold on. T is 0 to 12. That's just giving me my window range. Not telling me what to do here.
No, okay, you're putting your rate, that's the 5 years, or it says where T is the year. Now where do you
T is the year, so that's my variable. So my function is going to be P is 40,000, 1 plus 0.05 to the T power. times the number of years, I can figure out how much money I would make after that many years if I just let my money sit. Now 1 plus 0.05, I can go ahead and do that. I know that's 1.05. Okay, so you can go ahead and add that. Okay, so if I want to graph it, I'm going to do 40,000 times 1.05 raised to the, not the t power, it doesn't understand t, you have to tell it the x power. Okay, now I'm not seeing anything, but I can see that it does understand my equation, so it times 0, and starting at 40,000, then I earn to 4,200 after 1 year. After 2 years, I have 44,100. After 3 years, I have 46,000. So I'm earning every year, and the amount that I earn actually goes up because all the money I earned previously is now earning interest. Now, in order to see the graph, I got to get my window range set. Now, they told me they wanted t from 0 to 12, so that would be my x range going from 0 to 12. And on my y-axis, it looks like they want me to go up to 100,000. Now, the problem with the graphing calculator, it doesn't go up to 100,000. So the closest I can get there is 99,999, and that will give us effectively the same thing. Okay, so sometimes if you need six places.
What answer did you come up with there?
Okay, well let's look at it. I should be starting at 40,000, which is about halfway up, a little below halfway. And then I should end up maybe a third of the way from the top.
Let's take every 1,000 units. I would assume they're going to use the same ticks.
B.
Yay.
Okay, so I should start about, it looked like on my graph I start a little bit below halfway and then I end up about a third of the way from the top. That's how I figured that out. This one is too low, this one is too high, and this one ends up too high. And it also starts above the halfway mark. So 40,000 should be below the halfway mark.
So we're off at continuous compounding. Back to the regular.
Yeah.
This is just annual compounding. Yeah, I'll find the continuous.
That's where I was confused.
I'll find the continuous problem in a second. There is one.
That's great interest right there.
That is a great interest rate. If you look at your actual savings account, it's probably like 0.05%.
That's exactly what it is.
Instead of 5%, yeah. Okay, now the future value. Now in Part B, you kind of have to look for what they're asking for here. Mine says 5 years in Part B. So the future value after 5 years, how can I find that really easily? Table. T equals 5. So I've already got this graph. My table, I just need to make that go up to 5 there instead of 4. So at 5 years, I'm at 51,051.26. They're always going to want anything rounded with money. They're always going to want it rounded to 2 decimal places.
Now,
So
where did you get your 5 compounded annually? That's the 5 years?
Where it says 5 years in Part B, you got to see how many years. Yes, Kyle?
How did you put that into the calculator or the?
Yeah, I didn't do that today.
Wish we had screenshots we could take. Can't print them.
You can. You can take them. You can print
You
them.
can just snip them too.
That's your.
Yeah.
That's pretty alright.
You got my
Hmm?
Instead of a sign was on the right, you obviously put it in.
Is that what you, with the X on the end?
Well, yours, like mine only wanted to go up to 100,000. Yours, you want to go up to 200,000. So you're gonna have to zoom it out a little more to get it up.
Careful, this thing could be negative.
But you just kind of imagine if it was cut off there.
Yeah, well, what I was asking is the X on, is that continue to the back?
I don't listen to you half the time anyways.
I'm just like,
Oh, it's the rounding.
Come on.
That's not rounded right.
you take like a half hour nap before you start.
Turn on your calculator.
You don't have to nap during that.
Round it.
Nap time, there's only one.
No. I'm not trying to put it
You can try it if you got the chances.
Okay.
Power nap, there
So
we go.
sometimes it doesn't round very well.
Alright,
Sometimes
so
not
how do you
quite,
graph
it
this
usually
stuff?
it should be
I'm
okay.
not
Just
finished.
dress it
I'm
down.
missing.
Oh, it's the X. What do I think? There's 12 here.
When you go here, what
Hold on,
number do you
Oh,
take?
by X. Duh. It is X.
Alright guys, I wanna, is everybody got 15 okay?
No. Let me put my answer in.
I just wanna put the 7 in there.
I don't know your.
Your answer from the table?
Okay, she's got
If it's not taking your answer from the table, try it in the calculator and make sure that the table, probably your table isn't rounded correctly. Sarah? So what was yours? What was your principal?
We're not gonna change anything here.
70,000.
70,000.
My interest
How did
rate
she
is
come up with
3%, so 0.03, and then I have it for 20 years.
Okay. If it's not
She
taking your
did
answer from the
something
table,
in
put it in your
terms of
calculator, make sure it's rounded
what did
correctly.
she take?
So 126,427.79.
I think she took the end of it, which is
Didn't round up right.
It didn't round it up. Yeah. So you can find it from the table, but it's safer to use the calculator and punch it in directly. Mhm.
The 1 plus the R
What
makes
number are
mine.
you looking for to
Yeah.
put the 10 years?
Yours it from here.
You don't have to do that. I just do it to save key strokes.
If I put 10 years, and I did that.
All right, so it's time for a break. Let's do a break, and then we'll come back and we'll look at continuous compounding.
I think it's because
At about 12:35.
She said that tends to kind of round it differently than a calculator does.
That's what it was.
Yeah, I'm sore.
Man.